ठीक है। Hello. Yes. Shall I start?
Yes, sir.
Okay. Is the slide is visible?
Yes, sir. Visual.
So please
No,
confirm
sir.
whether the slide is moving or not. Please tell me slide is moving.
Yes, sir. Moving.
Please tell me slide is moving, na?
Yes, sir. Moving. Continue.
Okay. So yesterday that you have already completed this up to the character diet or the very calf. So let me start also today. That is PIN diet. Okay. So in this PIN diet actually, so first let me introduce actually what is PIN. So all of you know this that's a APN diet. It is simple abbreviated as actually positive, intrinsic, negative diet. So in short, actually we are telling PIN. Okay, it is a semiconductor tool that belongs to that of the per diode family. As like the part this is so other diodes like your power diode, LED, laser, solar cell, photodiode or varicap. Okay. Similarly, pin diode is also one type of part semiconductor diode. It has also the two terminal. Okay, you can see this is the part one typical part pin diode. Okay, and particularly I think that in the market that when you are using the parts such type of diode for the making any of the devices, it is this type of diode is actually part more plenty available. And this is actually I'm putting it here. It is called P positive. P type actually high quality semiconductor layer. Then intrinsic that is called on-doped or gently doped semiconductor layer. And the N type is called the part that is on-doped. That is called N type is a part pure or that is called semiconductor layer. It is a poor, it is a high quality, and this is called the intrinsic. So the purpose of making of this such type of diode is what? Actually, we are intentionally making one type is actually highly dense and other is part low, that is called highly concentrated, other is part low, and the intermediate is actually is a part on top. So where we can make the part substance become highly active by injection of the part charge carrier from the high intense area to that of the part low intense area. Okay, like from the P type, you know this is a high quality, and N type is a part poor quality, but in between them there is a part intrinsic layer is there. So we may make the part flow of the charge from high quality to the low the part by through the part intrinsic layer actually. The intrinsic layer performs a crucial role within the device operation, permitting it to characteristic as variable resistor in reaction to an implemented voltage actually. So the intrinsic rule actually plays a crucial role within the device operation. So that is why the name PIN has have a special importance, because it particularly it creates the part more number of charge carrier by the flow of the part current from the part P type to the part N type. Okay, so this PN diode is one type of photo detector used to convert optical signal into electrical signal. Okay, remember this PN diode particularly used, it is used as a detector. Okay, that means it can simply convert the light signal to that of the part electrical signal here. Okay, so this is part actually this is why it has a part some special features that we'll discuss. Okay, next is we coming to the part its construction, how the PN diode actually part get constructed. So if you can look to the part diagram, just you can see this is P plus contact. Okay, and this is a part N type contact, and that is part actually intrinsic layer, that white color that is given the part intrinsic layer. Okay, so and these are the part metallic contact to provide it to just to allow the part the flow of the charge carrier through the part circuit actually. Okay, so you can see this the part a symbolic representation. Okay, so P diode consisting of the two layers of semiconductor and one layer of intrinsic material in between them actually. So this is intrinsic layer, and there is a part you can see this green or this part blue is a part actually part P that is P type, and this pink color is part N plus. Okay, and there is a part N type layer again, and this is P type, and the this orange color is given part P plus. So P plus is actually highly doped as compared that of the P region. Similarly, one another N plus contact is given. This is this is poor doped as compared that of the part N actually. And in between part these layers, we are putting actually a part intrinsic layer, which is actually plays a part major role in flow of the charge carrier. Okay, so pin diode can be constructed into two ways using planar structure and also mesa structure, means networking structure. In a planar structure, a very thin epitaxial layer is fabricated on the P substrate. You can see this is a P substrate, and over this we can make develop a part a P plus contact or epitaxial layer, and similarly over N type layer we can also develop a part N plus layer. Similarly, epitaxial layer is fabricated on N type substrate, and that will be comprised of N plus region, and in between this semiconductor a layer of intrinsic material of width 10 to 200 micron. This is called your part intrinsic layer of resistivity 0.1 ohm into meter is introduced in between the part this P plus region and also the part N region here. Okay, so semiconductor layers actually provide the ohmic these semiconductor layers are provided the part ohmic contact by providing the part metal actually. Okay, so this is the part construction details of the part pin diode here. Similarly, coming to the part working of the part PN diode, it is the PN diode also the working is similar that of the part general diode actually, similar the general diode. When P diode is actually unbiased, okay, it is unbiased. That means there is no charge. Means it is unbiased means there is no biasing is given. The charge carriers will flow from N type region to that of the part intrinsic region due to the part concentration gradient. I told when there is no biasing is given, so the charge carriers are simple move from P plus region to that of the part intrinsic region actually. Okay. So then what happened actually? So this width of the deflection region at Ni junction, intrinsic or N-type material, will be more on N side and less than part less on part I side. So all of you can mark here one thing. Just you can see when there is flow of the charge carrier takes place from this P plus to part N region, there is a part deflection region, or there is a part you can see this is called the deflection region that is formed at Ni junction. N is a part this one, and this white is a part I. So this Ni junction you can find a deflection layer. So this deflection layer actually will be more on N side, because as N side is part heavily doped, and also the part I side is a part purely doped. So naturally, a heavy depression region is get formed at the Ni region. The region behind this N-type material is part, because N-type I told heavily doped, while the intrinsic layer is not doped, or doping level is part extremely low actually. Okay, so that's when charge carriers, that is electron from the majority carrier N-type, flow from N-type to intrinsic layer, the depletion region will be created, but the width of it, both the side Ni junction will be different. That means you can see that as this N-type is actually heavily doped and this is for poorly doped, so through this junction, the majority charge carrier, that is called electron from the N-type region, will move from this N-type to that of the intrinsic region. Similarly, the charge carrier will flow from the part P plus region to that of the part P to the part intrinsic, that is called Pi intrinsic, Pi depletion region, and this is called Ni intrinsic region. So within this part intrinsic regions, there is a part combination of the part charge carrier takes place, and finally that will constitute the for diode current actually. Okay. Now, so after that we have a part frequency response. So the frequency response of the PIN diode is crucially in determining for applications. Actually, whether it is operating high frequency region or that is a part of the low frequency region. So accordingly that we have the part different conditions. So if you can go for the high frequency region or high frequency operation, you can find the width of the intrinsic region minimizes the capacitance. Okay, because as there is a due to the part density different, actually there is a diffusion of the charge carrier takes place from the part heavily doped region to that of the part the lower doped region. As a result, what happens, the width of the potential barrier goes on part decreasing. Okay, so the width of the part, you can see the width, the wide intrinsic region minimizes the part capacitance, allowing the part PIN diode to operate effectively at a high frequency upon in the part gigahertz range. That means when there is a heavy frequency or the part there is a heavy current will also flow, that the part the capacitance capacitor also part minimizes. Okay, switching speed actually part, the absence of the stored charge in the intrinsic region enables fast switching times, making it suitable for RF applications. Okay. So this is a part, the switching speed, and this happens basically in the part low frequency region. Okay. Now coming back to the part application of PIN diode, so it has a part large applications like for RF and microwave switches, attenuator, photodetector, limiters, and phase shifter. So you can find the part many of the part applications in the part of this part PIN diode actually. Okay. Now I'll be come back to the actually. So this is the part simple. You can see RF microwave, attenuator. Attenuator the device actually which can decreases the part intensity, the strength of the part signals. Similarly, come to the photodetector. Those that can operate or that can act as a part sensing element in presence of the light. Then the limiters also there. Okay, and the phase shifters. So these are the part some of the applications that you can find of the part PIN diode here. Okay. Now, so what is the advantages of the part this PIN diode? So you can find this PIN diode have the many applications. 1 minute. Yes. Am I audible to all?
Yes, sir.
Yes,
Yes,
now
sir.
Yes, sir.
Yes, sir.
Hello. Yes. Anyone want? Anyone saying anything?
Continue, sir. Carry on.
Please tell me it's not audible, please.
Nothing, sir. They just reply that you are audible.
Sir,
Am I audible to all?
continue.
Yes,
Yes,
sir. You
sir.
may continue, please.
Fine.
Audible,
Fine.
sir.
See, so what are the advantages of the PIN diode actually? So it has actually high reverse breakdown voltage. So I yesterday also I told you the part what is the breakdown voltage. So it can tolerate, or it can actually resist the high breakdown voltage. The width of the, because as you know, there is a part P plus region over P type, and also the part N plus N minus region over the part N type. And within that actually we have the part intrinsic region. So due to that actually that this diode actually possesses a part high reverse breakdown voltage. So, and this is only developed due to the fact the width of the depletion region developed at the IN junction and also the part IP junction. So that is why you are written here. The width of the depletion layer in pin diode is very large. It imparts its ability of high reverse breakdown voltage, and also it is suitable for protection of circuit from a large current. That is why it can be used for the most of the circuit, without any risks. Then the high capacitance also it has, because as you know, the since the intrinsic regions are actually connecting both the P type and also the N type, so it can act, or it can increase the per charge storing capacity, for which it has the per large capacitance. So you can see the width of the intrinsic layer is large, due to which capacitance of diode is low, as the capacitance of the device is inversely proportional to that of the distance between the per electrode. All of you know C is equal to epsilon 0 A by D. So when D will be part more, then capacitance will be less. But when D will be part less, capacitance will be very, very high. So according to this formula, it has also part high capacitance. Okay. Similarly, it has also part photo detection capacity. So due to large width of the intrinsic layer, the photons striking the surface will be more, because I told intrinsic region plays a vital role in the part, yes, in describing the working of the part, the pin diode. So it also helps in photo detection, because due to large width of the intrinsic layer, the photons striking the surface will be more, and the generation of the electron hole pair also part increases. These are the part, some of the advantages. Okay. Then you can come to the part disadvantages. That is called the part just one of the part, the small disadvantage, like a high reverse recovery time. It is actually the pin diode has high reverse recovery time, due to which power losses are significant. So this pin diode may be cause also the part some power loss due to its high reverse recovery time. It will not actually come back immediately, or not recover the part current immediately. So as it is not able to recover the current immediately, so it has high power loss. So this is one type of disadvantage. But other than this, we have the part good advantages are there by giving the part intrinsic layer. Okay. Now I put a simple comparison between the pin diode and also the PN junction diode. So you can see structure. So in PN junction diode, there is no intrinsic region, but in case of the pin diode, we have put apart a 3-layer structure, like we are putting apart intrinsic region. Okay. And you can see in pin diode, doping is part lightly or undoped intrinsic layer, but here you can find heavily doped P and N layer. Okay. 1 minute. Okay. Then the part coming back to the part operation, actually you can see that the pin diode have a variable resistance and fast switching, and but in case of the part PN junction diode, the basic diode function actually rectification. All of you can see operation. It act as a part variable resistor and fast switching process, but PN junction diode can only act as a part rectification process can be done by this. Okay. Now switching speed is part very fast, because here large number of charge carrier, but here you can find slow due to less number of charge carrier. Okay. Then applications, what you can find RF switching and also the voltage control attenuator. This is completely done by the part P pin diode, but here you can find only rectification and voltage regulation or act as a stabilizer. Okay. Similarly, recovery time is very low, but here you can find higher and leading to slower switching times. So these are the some comparison between the PN junction and also the PIN diode here. Okay. Am I clear to all of you?
Yes, sir.
Yeah.
Okay.
Yes, sir.
Okay.
Sir, what is the commercial applications of this?
Yes, please tell me.
Sir, how you can use commercially the pin diode?
Yes, it is commercially. So you are asking. So I think you are asking questions how it is commercially available or what you are asking.
Yes, how it can be commercially leveraged? Yes, applications. How to visualize this particular issue is pin diode?
Yes.
Can you, please, sir?
You see, due to its but actually it's a high efficiency. That pin diode. I think you are asking how it will be commercially available or actually just your voice is less audible. So
Yes,
I'm
sir.
not
Yes,
getting.
you're right, sir. Right, sir.
Hello.
Yes, sir. Fine, sir. You proceed. Go
Okay.
ahead.
Okay. Just if you any query, you can message me also. Okay.
Okay, okay, sir.
See, now coming to actually part tunnel diode. So just like your part pin diode, the tunnel diode is also part very heavily dot PN junction. You look to the part this diagram actually, you can see there is a part FP part a tunnel diode here. Okay, and in a tunnel diode, electric current decreases as applied voltage increases. But in most of the cases, you have find in all other diodes with increase of the voltage, current actually rises up to a certain value. After that voltage, it is sharply rises. Like in general, any general diode you can find. But here you can find one thing that is called the part tunnel diode. And that tunnel diode actually it basically comes due to the per tunnel effect in a semiconductor. If you have the per idea in per tunnel effect in per quantum mechanics, that is actually arises. So that is why in tunnel diode electric current decreases as the applied voltage increases, and at a high voltage it works as a ordinary PN junction diode. Okay, so just this is the particularity you can find in tunnel diode. Okay, in tunnel diode electric current is due to tunneling effect. You know, tunnel is a part of structure where there is a part a very narrow region or narrow path is there. Whenever any charge particle has to move, then its behavior is far different. So that is called actually for tunnel effect. Okay, so due to its fast switching ability, it is used in high frequency oscillator and amplifier. Clear? So due to this tunneling effect, charge carriers are moved across the deflection layer at very low voltage. Okay, and the circuit shown below the symbolic diagram of a part tunnel diode. This is the part symbolic representation of a tunnel diode. If you can see, this is not present in the other diodes, which is present in the part in tunnel diode here. Okay, so in tunnel diode, the P terminal act as the anode and the N terminal simple act as cathode as usual. Okay. Now coming to the construction of the tunnel diode, you can see the device is constructed by using two terminal, namely anode and the part cathode. Okay, here you can find also the part anode and part cathodes are part there. Okay, so the P-type semiconductor act as anode, N-type semiconductor act as metal act as cathode, and the gallium arsenide, germanium, gallium antimonide are used for manufacturing of the part tunnel diode. As all of you know, this gallium arsenide, germanium, all are part compound semiconductor and having the part that a high ability or having high affinity can create the part large number of charge carrier. Okay, so the ratio of the peak of the part forward current to that of the value to of the valley current, it is maximum in case of germanium and less in part silicon. So what basically we are putting germanium to make it the part construction due to part these advantages, not actually silicon. Hence, silicon not used in fabricating the part tunnel diode. So all of you remember, so silicon never used for making tunnel diode, but rather we are using germanium due to this actually this region. Okay. So the doping density of the tunnel diode is 1000 times higher than that of the part any ordinary diode. So you can see in ordinary diode, we can doping actually minus 10 to the power minus 3 or minus 4 or minus 5. But here you can find 1000 times more dop in case of the part tunnel diode here. Okay. Now, coming to the part working actually. So all of you can see. So this working of the tunnel diode can be explained on the different contexts. So let me go one by one. So this is the part, the general tunnel diode or the general tunnel diode part region I am showing. Width of the deflection region depends upon the level of doping in semiconductor material. So this width actually depends on the how much the part materials part get doped. Okay, if the doping level is high, then the width of the deflection region is part thin. If the doping level is low, then the width of the deflection layer is part more actually. Okay, just remember how the width is depends upon the part doping level. So higher doping, the low width, the doping level is low, the width is part layer is part more. Just it inverse related actually. In tunnel diode, the width of the deflection region is very thin because tunnel diode is part very highly doped, because you have seen na. So we are making the part substance 1000 times doped more than that of the part PN junction diode. So naturally, as doping is very high, so naturally width is very low. Thus, when low voltage is applied across the part, the terminal. So when I can apply very low voltage across the terminal, then the forward biasing electron move across the deflection from N type region semiconductor towards the part P type. So when you can apply the forward bias, so naturally the flow of the electron takes place from the N region to that of the P region. Okay. Now I'm coming to the part different situation. So in which cases you can find there is current is there or not. We can discuss the part in 4 to 5 situations. All of them mark carefully. So this is first is unbiased tunnel diode. Unbiased tunnel diode means there is no biasing applied. So you can find this is a part energy of the valence band. This is the energy of the conduction band. So naturally, how many number of part electrons or that is what the charge carriers available in the valence band, the same number of charge carriers also available in the part conduction band. So that is why we call actually unbiased or intrinsic condition. In an unbiased tunnel diode, no voltage will apply to the tunnel diode. Okay. Here, due to heavy doping conduction band of N-type semiconductor overlaps over the part, the valence band of the part P-type. You can see conduction band of the P-type overlap over the valence band of the part P-type also here. Okay. This is in P-type and this is also part N-type here. Okay. Electrons from the N side, electrons from the part N side and holes from the P side overlap with each other and they will be at the same energy level. Okay, you can see the same energy level they occur. Electrons from the N side hole from the P side overlap with each other and they will be at the same energy level. That is why as there is no exchange or diffusion of the charge carrier takes place, so there is no current. Even if that they are heavily doped, you can see there is no voltage and no current. It is completely empty here. Okay, have you understood now? Yes. Hello.
Yes, sir.
Is it understood to all?
Yes, sir.
Yes, sir.
Sir,
It's
why
clear.
there will be no current?
Yes, sir.
Yes, sir.
Yes, you can see there is no current because there is no what movement of the charge carrier takes place from this part valence band to that from P type to N type or from the N type to P type. That is why you can find there is no current here. Okay, because you are unbiased. This is not biasing is not done here. Hello. Yes.
Yes, sir.
Now, so you see, I applied the small voltage here. When I apply the small voltage, then what will happen? So the electron from the N type will move towards a part P type. And accordingly, you can see when we apply some bias or some voltage, as there is few electron are part simply transferring from this N to P type, so the current is slightly increases. So this is small tunnel current. Clear? Okay.
Yes, sir.
Now,
Okay, sir.
you can see when I gradually increase the FUT voltage, that means more and more number of electron will be simple transfer from the N type to P type. The natural current will be more. You can see. Is it clear? Okay.
Yes.
Now, just you can go again. I increase the voltage. So naturally, what will happen? Just you can see when I increase the voltage, all of you can see there is here you can balance band is part are the same energy level, But when you can increase the voltage, you can see this energy level difference is created, and there is movement of the electron takes place from N type to P type. And accordingly, you can see the current is also increases, got the maximum, and after that the current again start to decrease. Why? Because the electron may not be part more flow from the high energy level to this low energy level. Okay, that is why it is so initially it goes on increasing, then it got maximum, then goes up or decreasing. Again, if you can see, when you can largely increase voltage we apply, when a large voltage is applied, you can see this energy level in N type is part highly enhanced, whereas in P type it will decrease, and current is goes on initially increasing, got maximum, then decreasing, and again it is goes to part maximum current. Okay, that means when we can, after the part getting a saturation value, the current is decreases, and once we get another part decrease, again the part current increases due to the more moment of the electron takes place from the part N side, that of the P side. Okay, this is the part that things are described in the part in the here actually. Okay, all of you can see now. So coming back to the part VI characteristics, all of you can see I have already told you. So when there is low voltage or there is no biasing, the current is zero. When gradually the biasing is increasing or you are applying the voltage, the current, the moment of the electron takes place from the part N type to the P type. So current is goes in increasing, got a peak value, and after that it is again decreases due to the change of the part energy level from N type to P type. Okay, so this is the part trend of the VI curve for a tunnel diode. Am I clear to all?
Yes, sir. It's clear.
Yes, sir.
Okay, fine. Now, coming back to the applications, you can see there are some of the applications of tunnel diode. That tunnel diode can be used as a switch, amplifier, and also oscillator. It shows a fast response. It is used as a high frequency component. It acts as a logic memory storage device, because as you have seen that the part increasing and decreasing value of the current on the different condition, so naturally it can be used in some cases it can as a part storage device. They are used in oscillator circuit and also the part frequency modulation receiver, like in our part in our radios or the part FM channel. Okay, since it is a low current device, it is not used more. So wherever it is actually required, we just a very high, then it is used. Otherwise, it is not generally used actually, because due to some fluctuation in the part IV value, we are not using part regularly. Rather, you are going for the PIN diode or PN junction diode. Okay. Now, I'll come to the part actually gone diode. Okay, it is also another part interesting type of the part diodes. Like it is a transferred electronic device which is composed of only one type of semiconductor. All of you can see in all the cases you have seen where the two type or two layers are there. In some cases you got three layers are there. Okay, here you can find it is a transferred electron device which is composed of only one type of semiconductor, that is N type, and utilizes the negative resistance characteristic to generate current at high frequencies. All of remember. So one type, but we make it only N type, and utilizes the negative resistance characteristic to generate current at the high frequencies. Okay. So this is the part unique feature in GON diode. It is used to generate RF and microwave frequencies. It is composed of only one N type of semiconductor, because N type semiconductor has electron as majority carriers, and transferred electron devices use such material which have electron as a majority charge carrier. Not P type. P type is contain the whole, which may not be contribute that of the part more current, but electron can be contribute the part more number of part more current to the part any devices. So that is why it is intentionally made up of the part N type semiconductor. Okay. Now coming back to construction, actually, all of you can see the GON diode is made up of only N type semiconductor, because the transferred electron effect okay, only occurs in N type material and does not occur in P type material, because it is only appropriate for electron, not for the hole, what I told just few minutes before. Okay. So the material used in case of our gun diodes are part gallium arsenide, gallium nitride, indium phosphide, indium arsenide, indium antimonide, cadmium telluride, cadmium sulfide, and zinc selenide. Okay. So this is the part, the construction. You can see whatever the things, only one type N plus N plus N, and that is called the part a buffer layer. Okay. To just it is given to part to just allow the part charge carrier to flow from one region to other region, and this is the part metallic contacts are part given. Okay, this is the part the structural the detailed part the structural composition of the part, this gone died here. Okay, now first of all you should understand actually what is gone effect. Listen, this gone effect was first studied by J.V. Gone in 1963, and in certain semiconductor material he was observed such as gallium and indium phosphide has two value in conduction band. All of you if you have ideas about the conduction and valence band, so in this material you can find there are two value structure, upper valley, lower valley, and in our part in valence band there is part one single valley that is actually concave upward actually. Okay, so there is a small gap between the two valleys. You can see part the small. So this is the part base layer. Okay, there is a small gap between the part two valleys here. So electrons initially resides in the valence band here. So it is a part common thing. Okay, after gaining certain energy equal that of the forbidden energy gap, so what happens? Okay, the electrons jump to the part conduction band. At first, the electrons are in the part in the lower valley, where the electrons have very small effective mass and high mobility. So initially they are in per valence band, so that is why they are contributing part more in the valence band. Okay, but when they gain some energy, they make the transition from this band to this band. Okay, so the semiconductor behaves ohmically, means ohmic conductor. That is, the current increases with the increase of the per voltage. As the energy gained by the per electron in the lower valley increases, okay, this lower valley increases, what happens actually? They jump to the upper valley. So when current is part high and the energy also part high, so they can make a jump from the lower to the part higher valley, where the electrons have large effective mass and low mobility, where in the upper valley region. Okay, therefore if the electrons move to the upper valley due increase in the applied voltage, the current through the semiconductor decreases. Okay, and this electron transfer between the two valley is known as transferred electron effect, or that is called the part Gauss effect, named after the part physicist. Okay, so this is called the part Gauss effect that is happening in a part in a Gauss diode due to the part application of the voltage. Okay, so this is happens. So now then how it is work actually? So the Gauss diode works on the principle of the part Gauss effect. Okay, that's I told. When voltage is applied in an electric field across the active layer is part established. So once the active layers get established, then you can find what actually yes, you can find Gauss effect is part started. The current flows increases with the increase in the applied voltage. The device has positive resistance. The current increases until the voltage increases up to threshold voltage. Okay, so once the part actually part the current start to flow high value, the device is positive resistance, means resistance increases, the current increases until the voltage increases up to threshold value. So the current increases till we got a part maximum threshold value. When the voltage increases beyond the threshold value, okay, the current density start to decrease, known as the Gauss effect. The current decreases with increase in the applied voltage in this region. The device exhibits negative resistance. You see, under what condition it shows a positive resistance, and on what condition it shows the part negative resistance. When the current falls enter the active layer, the voltage difference across the parts active layer decreases, which does not allow another current flows to pass until the previous current pulse passes through the other end. So once a current start, so till it is not end, another current not start actually. Okay, the voltage difference rises again and another place, and another pulse start traversing the part active layer. Therefore, the operating frequency depends upon the length of the active layer. So at what frequency it can operate, so it depends upon purely on the part active layer. If the voltage is further increased beyond a limit called valley voltage or valley point, the current start increasing again and the device again exhibit the positive resistance. All of this here, okay. So with increase of the voltage, this actually happens here, okay. So this is how a gun diode actually operate during the part application of the part voltage actually. Then coming back to the VI characteristic actually, the VI characteristic curve shows the relation between the voltage and the current through the Gauss diode. In the given diagram, that how it looks like, you can see when here is a low voltage, current is low, but with the increase of the voltage, you can find the current is part increasing, got a threshold value, and once the threshold value is obtained, this is all the part positive resistances, and once the threshold value part threshold value rises or the part reach na, the current start to decrease with the part increase of the part voltage attaining a part valley point here, okay, and which is due to the part negative resistance actually, okay. So as you can see here, it is evident from this graph, the current initially increases. What I have told, that is same thing I written. With the increase of the upper voltage up to threshold voltage, once the voltage goes beyond the part threshold voltage, the current start to decrease as shown by the part negative slope here. And this region is known as negative resistance region. Okay. And the Gauss diode is utilized in this region to generate high frequency oscillation and also the part amplify the part signal. So this negative region have the part significance. It amplifies the signal. It is region the part, yes, amplify the part signal. It generate the part high frequency oscillation. All things that happens inside in the negative resistance. The current decreases down until the valley point and further increase the voltage. Again, it will start to part increase like that. Okay. So this is the part VA characteristic of the Gauss diode. Now, coming the part some advantages, you can find that part it has a portable size, portable and small size devices. The cost of manufacturing the part Gauss diode is low. It possesses better noise to signal ratio. Next, it has a high bandwidth also. Okay, and Gauss diode is a part reliable and stable at higher frequencies. These are the part some advantages. Similarly, it has also some disadvantages like it has a poor temperature stability, because once the temperature high, then it cannot also maintain. Okay, the device operating current is also higher. Then the efficiency of the Gauss diode is part low, below the part 10 gigahertz. Okay, so these are the part some of the disadvantages. Okay, now coming back to part application actually. The Gauss diodes are used particular for oscillator, amplifier, okay, and they are used for radio communication, military, communication radar sources, okay, and they are also used as fast controlling equipment, okay, in microelectronics for modulation of the laser. It is used in the part tachometers. You know, tachometer actually measure the part high speed part, the velocity of the velocity the velocity of the highly moving particle or high speed moving particle. Okay, Gauss diode is also used in sensor for detection in the trespass detecting system, indoor operating system, and also pedestrian for safety system. Okay, and also used extensively in microwave relay data link transmitter. These are the parts, some of the applications of the Gauss diode. Now, we'll come back to the part transistor actually. Okay. So as after the part getting the part, the details about the two terminal semiconductor diode and the different type, their behavior characteristic, responsibility, construction, working, okay, and application different side. We'll now move to the part another electronic equipment that is called transistor. Okay. So all of you may have read the part little bit from your part different carriers. Okay. So in the starting actually, let me go for actually some introductory idea about the part transistor. So all of you know that why you should go for the part transistor, not nowadays for the diode actually. Okay. So the large power consumption and the low reliability of the part vacuum tubes actually lead to your part interest on the part semiconductor based devices, which are operating on the basis of the part transistor action. Okay.
Sir, we can't hear you.
Yes, yes, yes. Hello.
Yes, sir. Yes, sir.
Okay. Yes. So coming back to the part, this is introduction. So all of you know the large power consumption and the low reliability of vacuum tubes lead to introduction of the part one semiconductor based device that can be easily switched electronic signal and electronic power developed in Bell Laboratories to investigate to semiconductor to replace these tubes by John Braden and also the Walter Barton under the guidance of the first Shockley. So that is why you can find the transistor history if you can go. This is for introduction. A transistor is a semiconductor device used to amplify or switch electronic signal and electric power to generate oscillation and as a also receiver. Transistor is symmetrical to a vacuum triode and reliability very small in size. Transistor is a composition of the 2-watt transistor and varistor. A transistor consists of the 3 layers of semiconductor material and each layer is having the capability of the transferring current to other layer, and it is composed of the semiconductor material usually with at least 3 terminals of the connection to an external circuit actually. Okay. So this is the part basic. You can see the 3-layer semiconductor device consisting of either 2 N-type or 1 P-type layer of material or 2 P-type or 1 type layer material. First type is called NPN transistor, other is called the PNP type. Okay, and the transistor symbols you can find but actually easy way to remember this actually PNP means you can see PNP point in permanently and never point in. So it's the easy way that you can but remember actually. Okay. Then here you can find. So this is the first symbolic representation that you can see actually. This is for the part NPN and this is for the part PNP. And you can see actually yes, these are the part the same symbol that I am showing here. Okay. Now coming to the part construction actually. A transistor is part constructed by placing oppositely doped semiconductor material between two similarly doped semiconductor, or placing N-type material between two P-type material, which forms the PNP transistor, or by placing a P-type material between two N-type semiconductor, which forms NPN transistor. Okay, just you can see, that means we are sandwiching one N-type material between two P-type material and one P-type material between the part N-type material. Okay, and these are the part logic symbols you can see, and this is the part just have a difference. For PNP, this arrow mark towards the base, and for NPN, this arrow mark away from the base. Okay, just you can see. Similarly, to the construction can simply explain with a two diode analogy for transistor. Okay, and here this is a part diode analogy. Just have the same things I explained to here. Just I put it here. Okay, and these are the parts, some physical characteristic of the terminal, and all the terminal having different names like emitter, base, and collector. Then the base input serve as a gate collector device for a large electricity supply. The collector is a larger electrical supply, and the outlet of that supply is the emitter. The current flowing through the per gate from the collector can be regulated by sending varying level of current from the base, and in this manner a very small amount of current can be used to control a large amount of current like amplifiers. Okay, so these are the different functions of the different terminal that you can read. Okay, then we are coming back to the principle of the operations. The fundamental principle behind all transistor is the current flows between the two terminals is prevented by energy barrier that has been set up between them. To operate the transistor, a third terminal is provided that allow to lower the energy barrier. The amount of current that flows between the first two terminals depends upon the extent to which the energy barrier has been lowered by the third terminal. Okay. So these are the things actually what I told for transistor action you can get. Okay.
Hello.
Yes. Hello. Okay. Just 1 minute. Okay. Okay. Just it has some issue actually. Let me. Okay. So then the coming to the transistor different configuration, like a transistor has three terminal. I've already told you the emitter, base, and collector. Okay, and you can see this is common base, common collector, and common emitter. This is the so these two circuit actually showing a a common base actually. Okay, like here the base is common between the part emitter and the part collector. Okay, so as the name suggests, the configuration of the common terminal base, this remains common for both the input and the output circuit. The voltage is applied at the junction of the emitter and the base. Here the emitter and the bases are referred to as input side, and the collector is known for the output side of the circuit connection. Similarly, common collector, if we can find, The collector, you can see this is part emitter, this is base, and this is a part collector. Collector is common to both the input and the part output. Okay, in both the cases. Similarly, you can see also the part common emitter, just on the orientation of the part terminal that we can put actually just like a part. Put the part between the, you can see emitter is common to both base and collector here. Okay.
কথা কওনো
Next, you can see, so transistor circuit actually, just I compare actually for the common base, common collector, and also the common emitter. Okay. So this is a part comparison that you can get voltage gain in terms of different parameter, voltage gain, current gain, power gain, all the things. Okay. Now, coming to the part working of a part transistor here. So to explain the working of a transistor, you can consider only NPN transistor. So what you can find, you can see that is a base emitter junction. So all you know the part in a transistor base emitter junction is forward biased and the collector base junction is part reverse biased. The width of the depletion region at the junction CB, okay, means collector and base is higher compared to that of the part width of the depletion in the part BE. You can see this is BE and this is a part CB. Okay. When the B junction is forward biased, BE junction is forward biased, it decreases the barrier potential. All of you know when it's forward biased, it decreases the barrier potential and hence the electron starts flowing from the emitter to that of the base. Means as it is a forward biased and the depletion region or the width of the junction is very low, this is the current to start flow from the part emitter to that to the part base actually. So the base region, as you know, the base region is very made thin and low drop. So what happens? Hence, it is consisting of a very small number of hole, and the electron that flowing from the emitter will recombine with the hole. Okay, suppose there are 100 number of electrons are flowing here, only 5% of the electron get combined with the hole, and other 95% will move towards a part, moving towards a collector, constituting the part collector current. A large number of electrons that are left will move across the reverse bias collector junction in the form of the collector current here. Okay. Now, besides on that, we can apply the Kirchhoff's law, that is emitter. That means since we have told the total current which are flowing from emitter, that is called to base and collector, that you can find actually you can find actually what this I is called IB plus your part IC actually. Okay. Clear? So this is the part equation, and the same things also happens for the part another part NPN transistor that I explained here. And this is the part the characteristic curve that you can find for the part is this is the part different characteristic characteristic curve of the transistor for the voltage VC versus the part IC. Okay, at the different region, like for the active region, forward bias region, and also the part reverse region. Okay, so this is the part. Just you can get the part all the things from this part notes. Okay, you can get you can read out here actually part. These are the why these are the straight line and how this is get increasing. That I put it here actually. Okay, so in the then coming back to actually part output resistance, you can see you can calculate the output resistance. Okay, that is from the part this VC versus the part RO. Okay, and similarly you can get the part current gain also from this characteristic curve actually. Okay, and similarly the current amplification factor that you may have read in upper graduation level. So here you can find beta SC. Okay, that is change in collector current by change in base current. Okay, and we can also establish the relationship between part this beta and part alpha. Beta is equal alpha by part 1 minus alpha, and we can also calculate the part collector current from this equations. Okay, this may be small problem, you may get it here. Okay, so this is for the part different also. Another part, this is for common is for the common base region. I just put all the things for the part base open. Here is a part emitter and collector. Okay, and this is the part the total details about the part the transistor circuit here. Okay, so we have completed the part these transistors in details actually, And in transistor, we will go for the actually part BJT. I completed the part. This is for the BJT, bipolar junction transistor. Then you can go for the part FET and also the part MOSFET. Okay. Hello.
Yes,
Yes,
sir.
sir.
Okay. So, if possible, I will put the part class tomorrow. Otherwise, as due to the part some other issue, I may not be. But I will take my part in general class, my scheduled class. So, if possible, I may take class tomorrow also. Okay.
Okay, sir.
Okay, sir.
Okay.
So today 4 to 6 class will not be there.
Yes.
But today 4
Sir,
to 6 class will not be there.
Not getting your question.
is there any other class for today, sir?
I don't know
Today,
actually because
today, today,
maybe
today no class will held at 4 o'clock because sir has accident. That's why sir has class taken class today. Okay, so there is no
Okay,
class at
sir.
4 o'clock. The 4 o'clock will shift
Okay,
to,
sir.
I mean, 7. So sir will inform us what time sir will take the class tomorrow. Sir,
Okay.
kali ketelo class nebe?
sir, if possible, sir, actually, because actually I have
Okay, sir.
some assignment is coming to me, so that is why I'm not able to actually fix the time. So I will be informed you, sir.
Okay, once sir will inform you, we will inform you through the SMS and mail. Okay.
Sir, I have one question. That will also further help us in your revision time.
Recording we will upload in our website. You can check it from our website. Okay.
Okay.
We will upload everything.
Okay, sir. Thank you.
Okay. Thank you to all.
Kindly share the
Thank you, sir.
presentation in the WhatsApp group that you are in, sir.
Sir.
Thank you.
अरे नेक्स्ट क्लास कब होगा? हाँ मेरे को है जगह 18,000 में खाई जाएगी तो जरूर हो जाएंगे। मरना आ गया विश्वास में चला नहीं कर